All right. And then, okay, you'll probably won't have nearly as many of these projects, but you'll see your projects, which is most likely only 2 of them. And that would be the one with your initial and surname, which is your final year project, and one that is called JW Uber or NM Falyun, the project of your supervisor, would probably be on there as well. And that is just a joint project that we've created, putting all of our students onto that one project, so that if we want to communicate with all of you, or there's general things that we need to discuss in the BPJ group, in the larger BPJ group, we can use that project and its issues. All right. So there's a lot of material on the project. There are some, if you star some of them, the ones that are really important to you, initially they will pop up, the ones that you visit more frequently. But you have to kind of highlight them and star them. So initially what you will have to do is you'll have to go to Explore Project, because there's a lot of other projects on the repository that you may or may not be interested in. The one that you should be very interested in, at least initially, and this is still coming via the web. This is nothing on your machine yet. All of this happens in the cloud on the server. Are there some of you who are doing this while we're talking? Yours are probably empty. So if you go to Explore Projects, do you also have these 2 projects, the VIP ones? Okay. In many cases, well, if there are public projects, you might see them, but in the end, what you'll have to click, at least the majority of you, will be to go to All, and the project that you should be looking for, I think you can just start typing here at the top in that box. You can just type Welcome. All right, and there is a repository that is called How To, and the project itself is called Welcome. And that project is when you are new to this optimization group, which the majority of you actually are. Right, and we'll go to that a little bit later. I just want to demonstrate in terms of where are we ultimately heading with this? Why is this actually important? How do we actually track it? What does it look like to talk about version control? And for the past couple of days, let me go to my projects. This is a project that I'm working on right now in terms of generating synthetic populations. And it says, Johan Uber authored about an hour ago, and he made a change, minor typo fixed, and that little funny code 183CA1ED is the version number of whatever the repository, the snapshot of the repository at that particular time. All right, so if ever I want somebody to work on a specific version, if you say, all right, Dr. Willemse, here is my proposal. I want you to look at this version. You give them that 8-digit code, and that is the version that we actually will assess. Right, and on that note, Dr. Willemse is unfortunately sick, so he tends his apology. All right, so I made some changes. I'm not quite sure where I fixed this typo. So if I click on that change, for example, I can see in what file the change was actually made in this repository, and it tells me that line 99, it's colored red, that line was taken out, and it was replaced with this line. So what it essentially means, I had a double the, and I took out the 1. And I can go through my document, I can go through any of my code, and I can see who made what changes. Right. This has got a lot of value, not just for you, but for us as well. So if you submit a proposal and you ask us for input, and afterwards you submit a revised proposal, we actually check what is changed in the proposal document. And whether you actually did what we suggested you should do. and not read the entire document. We started by saying, should I take this guy seriously? Yeah, they made the changes. All right, let me have a look at the document. Right, and you can see the entire track of changes that was actually made. There was one where we fixed column organization in R. So this is an R script. That line was taken out. This line was actually put in, and that was not the only change. Lower down in the document, so you see ... means there's a lot of stuff that didn't change, and then right at the bottom here in line 161, some things changed again. So it's a useful way to actually know who changed material in a particular document. You can't do this on an Excel spreadsheet or a PDF document. Right, because the problem with those are they are what we call binary files. They've already been compiled into a file that essentially is a bunch of 0 and 1s or hex values. So we tend to really love flat files, ASCII-based files, which is your CSV files, your text files, R script files, R markdown files, and LaTeX files as well. Those are all ASCII files. It's raw text, which means we can actually work with it and track the changes a lot better. So on Monday afternoon, you'll have a session on the LaTeX system for your document writing as well. All right. So I want to go back to the different projects. Explore projects. And there's a variety. I think there are probably a couple of hundred of projects already on there. Some of them are not accessible to you. Some of them actually are. As I said, the one that you should be interested in is this how to welcome. I don't think I unfortunately can change the resolution all that much. That is the address of a repository. If I were to so right there at the top you see https /how to welcome. In your final year project, let's take one as an example. Use Matthew's project. So you see the same first portion, irepo.up.ac.za/bpj2018/initials and surname.git. That is the address. If you've got access to that address, you can clone this repository. In this case, I think you all have access to one another's projects, with the exception of a few projects that we had to make or give limited access. But that is the address that you will use to do that initial clone, to actually say, I want this repository a local copy of, a clone of on my local machine. All right. So far, so good. All we've done now, the fact that we're using a browser means we are coming in via the web. This is not on my machine at all. How do we... Oh, no, I need that. Does anybody just have a sheet of paper for me, please? Okay. I'm going to make you my jumper. Can you ask that you just balance that in front of the light because we don't have a... Yeah. Just winch it in. All the way across. Thank you. All right. Now a little bit more technical, kind of some technical things that you need to get in place before you can actually start working with the repository. Is you need this bottom portion on your own machine. You need Git. Git is not standard with your operating system. Whether you're running Linux or Mac or Windows, you need Git first. All right. And it's called different things. There are different flavors or different ways of getting Git onto your machine. If you're on Windows, you probably can just download Git. You go to, or you just Google download Git, and you should be able to get a version of Git for either the 32 or the 64-bit operating system. I think if you're on a Mac, this is way too long ago for me to remember, you can get it via Homebrew. You can probably get it via MacPorts. If you don't know what it is, don't go there. Or you can probably download just an install file, the DMG file. Right. If you're on Linux, it's probably the easiest. You just do the normal package install, depending on what flavor of Linux you're actually running. Anybody on Linux? Nobody, usually not. Okay. So first thing is you need Git. Without Git, your machine won't know how to handle with all these funny and funky commands that you actually throw at it. Right, so step number one is you need Git. And secondly, you need a Git interface. You need something that you can say, all right, how do I engage with this thing which is right here at the bottom? If you're comfortable working on the command line, and that is probably only applicable to Linux users and to Mac users, I don't think there are many people that use a Windows command line. I don't think it's a very friendly Windows or a very friendly environment to actually try and work in. So you can work on the command line. I'm pretty comfortable on the command line, and I promise you, I rarely work on Git's command line because that really gets into the thick of things. Right? So an interface is a friendly environment with which you engage to actually do all this pulling and pushing and messing around with the data and the repository. There are a variety of these things, and I can start writing them down, and I'm going to stop and not do it because we've already done this. So instead of me talking through it, I want to show you how we want you to engage with this repository and actually get the stuff done. So what I want to do is just say, you need Git first. Without having Git, you won't be able to do any of the following. All right. So we go back to our projects, and we type welcome. And if you just scroll down, if you just scroll down to the kind of README file, it says, welcome to the optimization group. Whether you're a final year student working on your project, an honor student busy with your BCS research, a master student embarking on your dissertation, or a doctoral candidate embarking on the thesis journey, this is the start of a fascinating capstone project for your current season. This is where you get to express yourself through excellence, where you get the opportunity to let your knowledge manifest itself into a written artifact. Your first spot is the wiki. And if you click on the wiki, this is where you need to go. I don't have this, well, I have it, but you don't have this on your computer. You are still engaging with this server via the web. Remember that. So there's the welcome page of the wiki. The rest of the content we split into the three sciences. There it is again. The research process, the actual contents, and the packaging. Here we've split it around. The research process is something that you need to start off with. Then the content, and in this case we only kind of deal specifically with Python because everything else will be project specific. And then we look at the packaging portion as well. I really want to urge you to, as quickly as possible, go through this entire wiki. Right? This is where we try to capture our understanding and our experience, both good and bad, in terms of setting you up for success in BPJ. So please read through the wiki. If you do, you'll see that there's a heck of a lot of hints that you don't have to make all the mistakes yourself. All right, so there's an important one, effective student-supervisor interaction. And the next one that I want to take you to is finding your way with Git. And there it is, all the instructions that you need to know about Git itself. This document outlines some basic elements of Git, especially in the context of our workflow. First point, first you need Git. That's what we said. That's where you can get it for Windows. Download Git itself, and there's actually a link for you. Choose the right version. Once you install it, we suggest use a graphical user interface. Tortoise Git, and there's a link to everything else that you actually want to do on Mac. Here is the install if you want to do it via Mac ports. And there are some self-explanatory commands on the Mac side if you want to follow it. That is still Mac, 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 Mac. There's one for Linux. It's a one-liner. As a graphical user interface for Git, you may want to actually have a look at Git Kraken. It works on Windows, Mac, and Linux. And I know another one that more and more, I know Dr. Willemse used it, and he's quite happy, is called SourceTree. Do either one of you use SourceTree? Wonder wat gebruik jy? Okay. All right. I don't use SourceTree, but I use a package called Tower. And the nice thing about Tower, it gives me a much more graphical view in terms of, there are the 8-digit codes. That is the latest version. And different versions of me have committed to this repository. And this is the kind of the trail, the breadcrumbs in terms of the history of what was actually made. So mine is called Tower, but it works on Mac. SourceTree is free. Git Kraken is free. Let me show you a different one. If I go to, for example, These trees aren't always that kind of clean. Sometimes there are different branches and different people that are actually working on them. And it can become quite messy in terms of what the sequence of events are that different people have merged and so on. So what the graphical user interface does, it kind of sums up this in a kind of graphical, intuitive way. So it just helps you deal with the repository. The chances that yours will look like this is hopefully very low unless you mess things up. And we'll talk about the messing up because you'll likely do that, and that's also fine. All right, I want to get to this image. This is the typical, what I call the typical Git workflow. Initially, we said you do an initial clone. So that is the remote or the repository. It's also called the origin. And the first step, number one, is to clone it. Everything here on this side happens on your local machine. that's on the server. Right? You can engage with that server we set via GitLab, via this web interface, but ultimately, the most of the work will happen on your machine. Right, so you first clone it, you make an exact replica of what is the latest version. So what's not on the repository, you won't have. And that's why I say what's not on the repository does not exist, at least not for everybody else that you need to work with. All right. The second step, you do your magic. You make the changes, you create the folders, you add the documents, you add your graphics files, you add your R code, you do all of the work that you're supposed to do in your final year project. All right. But what you then need to do is you need to actually take and decide what of those bits of work do you want to group together and say, here I worked on my document. That file changed, and that file changed. These other files, that's something, that's programming, that's not my document. I pick the files, and I then add them into kind of a little package. And that's called the staging index. What is important to you is you need to add. You need to say, this is what I want to send back to the repository. So you add all of the files, and then you do a commit. That is step 4. This is an important thing. This commit is where I write those messages that said, I've made a change. This is what actually happened. And if you don't write proper messages, you make it very hard for other people to collaborate with you. Come on. Okay, I can't make it any narrower. Still trying to get blacklists working. I cleaned up the code. Fixed typo of changed, I can't remember what the rest is. Changed an erroneous folder name. Fixed the column reorganization. Minor typo fix. So it's an explanation for me for what was that specific commit about. And each one of those commits may have, in this case, one file modified. There's one file. There's one. Let's go to another one. We'll go down. There are 2 files that have changed. There are 2 files that have been added. And you get the idea in terms of what you, that you have to have useful commit messages. All right. So now you've commit. You actually said, I've got the files. I put them in the box. I wrote the address on the box. I got everything ready for the courier. It's now committed. The bill, what you call the bill of lading, is written out. It's done. It's ready to be picked up. The package is still on my desk. It's committed. Everything is packaged. Before it's packaged, you can still add and remove and add and remove. The box is not sealed. Once the box is sealed, it is actually committed. You can't rip it up, right? And rip it open again. But typically, we don't do that. So we keep the workflow clean. Once you've packaged it, it's in the box. Now you're actually ready to push it. Right, but that is step 6. What happened to step 5? At the bottom. First check, did somebody else not already change files in my repository? Because I don't know how other people have engaged with my repository. My supervisor or my girlfriend who had to proofread my document, etc. Maybe they've already made changes. So what is important before you push things to the repository is just do a pull. I'm going to focus on the pull, ignore the fetch. Focus on a pull to say, let me just pull any changes that were made on the repository. Pull it and make sure that there's no clashing things happening where we both changed exactly the same files and then there will be a conflict. Right, so it's important that you do step 5, do a pull, and do a push. Doesn't make sense? All right. First thing, this you only do once. Initially, you just create a clone of your repository once. Then you do your magic. as you go on back and forth, you add the files that you want to commit. In Git Kraken and in Tower, this is very much one step. As soon as you say, all right, tick box, tick box, tick box, let me show you what it looks like. If I were to, let's say in this R code, what am I, step 4? Add one more sentence. So now I'm in an R document, and I've actually changed the file on my machine. The server doesn't know that any changes have actually been made. Let me just go, I'm in the right one. I saved it. Oh, I just need to save it. As soon as I save it, my Git interface software, in this case Tower or your Git Kraken or whatever, will pick up, hey, something has actually changed. If I want to make sure what has changed, I can click on that file, view on the far right, and unfortunately the color is not that good, but there it actually says there was an empty line, now one line has been added, and it says one more sentence. As soon as I click that one, that little tick box, I've now added it. I said, this is a file. These are the files that I actually want to commit in this particular commit. So they are staged in this case. Another way is I can right-click on it, go the long way, and actually say, stage that specific file, which is exactly what we said there. That is the staging. Right, so or it can, in your software, it might just be a tick box. That is one of the files I want to commit. I need to add a useful commit message, demonstrate git to the BPJ 2018 group, and I hit the commit button. Now it tells me the latest version, to my knowledge, of the origin, which is on the server, of the origin is still at that point. That's where the origin is. My head, meaning the head of the snake of changes that I've actually made, my version is one ahead of whatever is on the repository. But somebody else may have actually made changes already. So what I'm going to do first, I'm going to do a pull. And if you have the option in terms of a rebase, I'll explain what that is. Use the rebase. It looks, it comes back, it says, no, everything seems to be fine. Done. I've did the pull, and I'm ready to now, oops, push. And unfortunately, the screen is not wide enough, but that head, the origin, actually moved up. There, that little logo that said, all right, this is where the repository is as well. So if I just go to, let me open up another one, repo. And here I can see there's a new 8-digit number for me. Demonstrate git to the BPJ project. If I want to know what changed in there, I can go and click there. And it actually shows me on the web interface as well that one line has actually been added. Right, and in the process, you can keep track of all the changes by following, this pretty standard workflow. So I want you to go through this entire page because I think it's important, and just understand this workflow. At this point, you may see, why all of this work? It is part of the process to make sure you don't lose anything and that we can keep track of what is being done in your project. And it's a form of a backup. Again, you clone, you make your own local copy, you do your magic, you decide what you want to send back, you stage it or you add it, then you commit it with a useful message. You just do a pull to make sure nobody else has changed it in the meantime, and when you're done, you can just push it back. And this is much easier to then do I'm tempted to show them a couple of cool things, but I'm afraid it might be a bit of, a bit overwhelming at this point. Maybe you can look at it later. When you write a commit message on GitLab, and you say, for example, so can you just close for us again? If there was, for example, an issue that said, I need to, Prof. Hubert, I've got this document, I cannot get this equation right in LaTeX, can you please have a look at my file, it's in line 234. And you create an issue, it's issue number 3, and you assign the issue to me. What I can then do is I get an email notification that says, right, you've addressed me specifically, there's a task that has been assigned to me, I do a pull on my side, I've got your latest repository, I can check the code quickly, and in my commit message, I then say, this closes issue #3. It gets pushed back to the repository, and I don't have to go to the web and say, all right, I'm done with this, close it. It picks up from the commit message that this is actually being done. Right. If I were to say, with a commit message, hey, at mmfried, knowing what the username of a particular user is, that person will immediately get an email with this commit message as well. So whatever I use on the web browser, I can use in my commit messages as well. And you may say, all right, is that really that valuable? Well, for me it is, because it can probably save 3 or 4 minutes of my time and allowing me to carry on with other stuff. Instead of having to open a browser, hope the server is responding, hope that it's fast enough, go into all the projects, go to the issue, type a note. It's much easier to just do that with one click. All right. Repositories. I'm going to ask you to jump up again.